Venn diagrams with universal set introduction. Venn diagrams are powerful tools for visualizing relationships between sets. What this means is, instead of just listing elements, Venn diagrams give us a picture of how different groups of things connect and overlap. We'll be using these diagrams to make set theory easier to understand. When working with set theory, it's crucial to define a universal set, the set containing all elements under consideration. Now, the universal set is a really important concept. Think of it as the big picture. It's everything we're talking about in a particular problem. It's the complete collection of items we're interested in. For example, if we're talking about students in a class, the universal set would be all the students in that class. In a Venn diagram, the universal set is represented by the rectangular boundary encompassing all other sets. This is where the diagram comes in. We show this everything, the universal set, with a rectangle. And inside that rectangle, we'll draw circles to represent the individual sets, the specific groups we're comparing. The rectangle acts like a border, showing us the limits of our discussion. This tutorial will guide you through representing the universal set in Venn diagrams, illustrating how it frames all other sets within a given context. Over the next few slides, we'll work through examples to show you exactly how to draw these diagrams, how to place elements correctly, and how understanding the universal set helps us solve problems. We'll start with the basics of drawing the rectangle and circles, and then move on to more complex examples with numbers and real-world objects. So, let's get started. So let's begin our discussion on Venn diagrams and the universal set. Representing the universal set. So let's move on to how we actually represent the universal set in a Venn diagram. As we discussed on the previous slide, the universal set is essentially everything we're considering in a particular problem. Next, everything inside that rectangle is considered part of the universal set. It's all fair game, all elements we're working with. And importantly, anything that is not within the rectangle is, by definition, outside the scope of our current discussion. We're essentially saying, we're not worried about those elements right now. It doesn't mean they don't exist, just that they aren't relevant to this particular problem. Now, let's look at a step-by-step illustration to make this really clear. Step 1, draw a rectangle. This rectangle, as we've established, represents our universal set, U. Step 2, inside that rectangle, we draw circles to represent the sets we're working with. It's crucial that these circles are completely contained within the rectangle. They can overlap, but no part of a circle should stick out. Step 3, the overlapping regions of the circles, where the circles intersect, represent the elements that are common to those sets. We'll see this in action with examples on the next slides. Finally, step 4 is really important. The area inside the rectangle, but outside all the circles, represents elements that belong to the universal set, but not to any of the specific sets we're focusing on. These are elements that are part of our overall context, but don't share the characteristics of the sets represented by the circles. Keep these steps in mind, because we'll be applying them in the examples coming up. Understanding where everything sits, inside the rectangle, inside the circles, or in the overlapping areas, is key to interpreting Venn diagrams correctly. Examples: fruits. Let's move on to a concrete example to really solidify our understanding of the universal set and Venn diagrams. Now suppose our universal set, which we denote as U, is the set of all fruits. Remember from the previous slides, the universal set is everything we're considering in this particular problem. So in this case, everything we talk about will be a type of fruit. Voiceover. Let's define two sets within this universal set. The first set, we'll call it A, is the set of red fruits. Specifically, A contains the elements apple, strawberry, and raspberry. Voiceover. The second set, B, is the set of citrus fruits. This set includes orange, lemon, and grapefruit. Now let's see how this looks in a Venn diagram. Voiceover. First, as we've learned, we always start by drawing a rectangle. This rectangle represents our universal set, U, which, again, is all fruits. Next, inside that rectangle, we draw two circles. These circles represent our sets A and B. Make sure the circles overlap. That overlap is important. Label one circle A for the red fruits and the other B for the citrus fruits. Now, think about what the overlapping region of these two circles represents. It represents the fruits that are both red and citrus. A good example of this would be blood oranges, if we were to include them in our set. So, anything in that overlapping section would be both a red fruit and a citrus fruit. The part of circle A that doesn't overlap with circle B represents the red fruits that are not citrus. So, that would be just the strawberry and the raspberry, as the apple isn't citrus either. Similarly, the part of circle B that doesn't overlap with circle A represents the citrus fruits that are not red. That would be the lemon and the grapefruit. Finally, and this is a crucial part, the area inside the rectangle, but outside both circles represents fruits that are neither red nor citrus. Think about it, what fruits fit that description? Bananas and mangoes are good examples. They're fruits, so they're inside our rectangle, but they aren't red and they aren't citrus, so they fall outside of both circles. This example should help you visualize how the universal set frames everything, and how different sets relate to each other within that framework. We'll build on this understanding with more examples, including numbers, on the next slide. Examples numbers. Let's move on to another example, this time using numbers. As we discussed in the previous slides, understanding the universal set is key to correctly interpreting Venn diagrams. So, pay close attention here. First, we're defining our universal set, which we'll denote as U. This U represents the set of integers, that's whole numbers from 1 to 10. So, U is equal to the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Remember, this rectangle in our Venn diagram will encompass all of these numbers. Voiceover. Now, let's define two sets within this universal set. We'll call the first set A. A represents the set of even numbers within our universal set. So, A is equal to the set containing 2, 4, 6, 8, and 10. Voiceover. Next, we have set B, which represents the set of prime numbers within our universal set. A prime number, recall, is a whole number greater than one that has only two divisors, 1 and itself. Therefore, B is equal to the set containing 2, 3, 5, and 7. Now, let's visualize this with a Venn diagram. Voiceover. Step 1. Draw a rectangle, and remember, this rectangle represents our universal set, U, containing all the numbers from 1 to 10. Step 2. Inside that rectangle, draw two overlapping circles. Label one circle A for the set of even numbers and the other circle B for the set of prime numbers. The overlapping area is crucial as it represents the numbers that are both even and prime. Step 3. What number is both even and prime? It's 2, so the overlapping region of our Venn diagram will contain only the number 2. Step 4. Now let's look at the part of circle A that doesn't overlap with B. This represents the even numbers that are not prime. Those numbers are 4, 6, 8, and 10. Step 5. Similarly, the part of circle B that doesn't overlap with A represents the prime numbers that are not even. Those numbers are 3, 5, and 7. Finally, step 6. What about the area inside the rectangle but outside both circles? These are the numbers that are in our universal set, from 1 to 10, but are neither even nor prime. Those numbers are 1 and 9. Voiceover. So, you can see how the universal set frames everything, and how each part of the Venn diagram represents a specific group of numbers within that framework. This is a really important concept, and we'll build on it in the next slides, so make sure you understand this example thoroughly. Key takeaways. This slide really solidifies the importance of the universal set, which we denote as U. Think of U as the big picture. It's the overarching set that holds everything we're talking about in a particular problem. It contains all the elements that are under consideration. Now, remember how we've been visually representing these sets. In a Venn diagram, the universal set isn't just a concept. It's the rectangle that neatly encloses all of our circles. Those circles represent the individual sets we're interested in, but the rectangle, that's U, holding everything together. And this is a really important point. What about the space inside the rectangle, but outside of all the circles? That area represents elements that do belong to our overall group, the universal set, but they don't have the specific characteristics that define any of the sets we've drawn circles for. For example, going back to our fruit example, that area would contain fruits that aren't red and aren't citrus. They're still fruits, so they're inside the rectangle, but they don't fit into either of our A or B categories. Finally, and this is crucial, understanding the universal set is absolutely vital for correctly interpreting any Venn diagram and successfully solving set theory problems. If you don't define U correctly or forget to include it in your diagram, you can easily reach the wrong conclusions. We'll touch on common mistakes in the next slide, but keep this in mind as you practice. Always start by clearly defining your universal set. Let's recap everything we've learned about the universal set with these key takeaways. Common mistakes. It seems simple, but it happens a lot. Students often get caught up in drawing the circles to represent the individual sets, like our fruits or numbers from the previous examples, and completely forget to draw the rectangle that represents the universal set. Remember, the rectangle isn't just a decorative border. It defines the scope of everything we're talking about. It tells us exactly what elements are being considered in the problem. If you leave it out, your diagram is incomplete and can be misleading. This is closely related to the first mistake. Once you have drawn the rectangle, it's crucial to make sure that every element you're working with is placed inside that rectangle. Think about it. The universal set contains all the elements under consideration. If an element is outside the rectangle, it means it's not part of our current discussion and therefore shouldn't be included in your analysis. It's like trying to solve a puzzle with pieces that don't belong to the set. This isn't about drawing errors, but about understanding the problem itself. Before you even start drawing your Venn diagram, you need to carefully read the problem and determine what the universal set actually is. For example, in the fruit example, we define the universal set as all fruits. But if the problem was specifically about fruits sold in a particular store, then the universal set would be the fruits available in that store. Choosing the wrong universal set will throw off your entire diagram and lead to incorrect conclusions. Always take a moment to think about the context of the problem to correctly identify what your overarching set should be. Let's move on to the final slide, which highlights some common mistakes students make when working with Venn diagrams and universal sets. This is really important because avoiding these errors will ensure you get the right answers in your set theory problems. So, keep these common mistakes in mind as you practice, and you'll be well on your way to mastering Venn diagrams and universal sets.